Bismillahirrahmanirrahim. Assalamu alaikum everyone. So we are going to conduct the second video on this 32-bit programming. And in this video, I'm going to share you the template program which we will follow in every source code or in every program, right? But before we start, probably you are noticing this white background in source code because last time it was black and font color was white. But now if you see move or start, you see that my background is white. So it is just more comfortable for me, and for visual purpose, I've selected this one. So if you want to do the same thing, you can go into tools, select options, and in font colors, you have various options available. You can increase your font size, you can change your background color, you can change your font color, and so on. So I have just selected it for as per my convenience. Okay, so you can do so for your as well, or if you are comfortable with the same with the default background, it's okay. So let's start. So this video is going to be all about the template program. So uh, I'm going to explain each and every line, which is important. And remember that I'm following the book of Kip Irvine for assembly language for x86 systems, right? So the book I'm following is Kip Irvine, right? So I'm going to start my code. First line of the template code is 38.386. This is basically simply a directive for MASM or Microsoft Assembler. And this directive let it know that you are going to program in 32-bit programming. So in command, I can say that it is just a directive for 32-bit programming, right? 32-bit programming. So if you use this .386 in your code, what will happen? All the registers will be of 32-bit, or memory addresses will have the data size of 32-bit, right? So that is what this directive does, right? The next thing that you use is .model flat std call. It is interesting. Dot model. Actually, dot model is the directive, and flat is basically its argument. Okay, so there can be flat, there can be small, and some other as well, right? But remember, what is the difference between them and why we are using flat? Flat actually assumes that all your uh, segment registers like EX, like ES, SS, CS, and uh, and data segment, right? DS. So these values will be selected, and they will be choosing the values depending upon the memory model. Okay, here extend dot model directive let you choose that specific memory model. To dot model flat is option for what? Flat is for single contiguous memory segment, right? Flat is used for single contiguous memory model, right? And in that specific memory organization, what happened? ES is equal to SS equals to CS equals to DS. Furthermore, they are equal to 0, 0, or they can take any value. But the most important point is that they are single contiguous memory. So they are actually representing the same memory segment. Okay. So it does not confuse your Microsoft assembler. And the next thing in this dot model flat dot STD call is basically STD call. STD call is nothing but standard calling. Okay, what it does do, actually it clears your stack, whatever the stack current stack, it will clear that stack before running this code. And furthermore, if there is any argument in the current state, it will save them, right? So std call means standard calling. It is a standard calling. So this line is doing that kind of stuff. So let me remove it. I hope you have understood it. The next thing that we're gonna do is we will define the stack, the runtime stack, which will be available for this program. It is not necessary that you will require that stake, but it is very a good practice. You always define stake, a runtime stake. So dot stake will be used as a directive, and you will define a size 4096 bytes. So it's like I'm defining 4096 bytes. You can take 100 bytes, you can take 1000 bytes, but since I'm following the Kip Irvine book and usually it's okay, this is Irvine. Usually it takes 4096 bytes, okay? Then we need to define a exit process, which is a prototype. Proto is a keyword for prototype, and you have to define its parameter, which is, let's say, dw exit code colon, and after colon we'll define the type of this argument or this parameter. So usually in 32-bit programming, we can take data type which is the obvious or inherent data type, which is double word. Okay, if you remember, there are different types. For example, bytes, you can use word, you can use double word. Okay, you can use uh, pointer. Okay, so there are various types. So here we have to define the type of this parameter, which is d word. Okay, we double word. Okay, so it's gonna take 32-bit because d word is compatible with 32-bit. Okay, so exit process is a process we are defining. So exit process is the name of the prototype. Proto is basically defining the keyword proto. D exit code is basically the parameter, and DW is its type. Okay. Next thing we're gonna define the data segment. Okay, the data segment is dot data. Dot data is for data segment, and here we will be using our what our variables. So we may need some variables like var1, semicolon var2. So all those variables. The point is dot data is a segment for variables. So whatever the variable you need, you will be defining under this segment. So dot data is defining data segment. Okay, data segment, and it is for what? Variables. Let me remove this, and then we are ready to for our main code, which is the dot code. Okay, dot code defines for your code segment. Whatever the code you want to write, you will write in under this uh, data type, under this directive. Okay, dot code is a directive for MASM, Microsoft Assembler, that from this point you will be starting your code. So, and in code, you will be using what? You will be using some procedures. Usually, if you write a high-level language, usually define void main void, right? Remember, this is what you do. This happens in high-level language. And if you are interested to define some user-defined functions, you call those functions within this main body, right? So similarly, in assembly language, you have procedures. You will have a main procedure in which you will write your main code, and if you have some user defined procedures or subroutines, you can call those procedures. Okay, procedures, it is equivalent to subroutine. Okay, so you will have to define your main procedure here, main procedure, and under the main procedure you can call various procedures or user-defined procedures. In this template program, we will be adding only single procedure, which is our main procedure. So how to define your main procedure? You write the label of the procedure or the name of the procedure, which will be procedure, which will be main. Okay. Then you write the keyword proc. Okay. You can turn off your caps lock as well. So you can simply write procedure. Okay. Main procedure. Okay. Then you're going to write the code, whatever the code or whatever the instruction, assembly instruction you're going to write. This will be your code. Okay. Okay. Let me press here tab just to, yeah. So that will be your code. Okay. Assembly lines. Okay. Assembly instructions. And at the end of that main code or the main procedure, okay, or the main subroutine, you will have to terminate the main procedure. So how you do it? You mention the name of the procedure, which is main here, and you write word and p. And p means ending the procedure. Okay. So this will be ending stage of this main procedure. Okay. But you know that we are just writing a template program. So it may happen that you will have number of procedure. One is your main procedure and other are your supporting procedures or subroutines, which you are calling within this main program. So after this, you will be using user defined procedure. You will be mentioning user defined procedures. Okay, procedures. If you are done with your main code, you are done with your user defined procedures, and you want to terminate code, what you will define the directive which will tell the compiler, tell the assembler that your code is done. Okay, so you have to use a keyword and. Okay, and is directive which tells the compiler that now you are ending the code. Okay, but it requires a label here. What label? Label is what the entry point of the code segment, where you started your code segment. Okay, so if I go back at this point, dot code segment, it was the start of the code. And okay, this was just for the explanation purpose. Let me delete it. So my code was started at the word main. Remember, this is the main label, which is defined for the main procedure. So this is the first point of the code. Okay, so or the entry point of the code. So this label we will use over here. Okay, label main. Okay, and that's it. And after that, for example, you write any code, any piece of code, any piece of code. Okay, any piece of code, it will be considered as a comment by the Microsoft assembler. So rest of the things or anything you write after this end directive, it will be considered as a comment. So you don't need to write anything, or if you are writing something, it will be missed. So somehow you have to complete the code before this end directive. Okay, so let me delete it. Last thing that I want to also include, which is kind of the part of sample project. And if you remember, we were defining this prototype exit process. You have to mention it in the main code. The very last line of the assembly code should be this, or the main code or the main procedure should be this. What invoke? Invoke is a directive for Microsoft assembler. It invokes the process or prototype. Which prototype? Exit process, which we defined earlier, comma 0. It is its argument. Okay, so what will happen? Exit process, this is the what this is process, there will be double s. Okay, so this is the prototype which will be invoked by this invoke keyword, and it will take argument 0. And remember, d exit keyword colon d word, this line, this was double word, and the argument value is 0. So I just want to mention here the full explanation you can find in the Kip Irvine book as well, or you can search in any Windows APIs. It actually indicate the termination of the current process. Okay, so this invoke line will indicate exit process. So this exit process will execute, and if it will take 0, that means the termination of the program or the last program was successful. Okay, if for example, if it takes 1 or any integer, maybe 2, maybe 3, it will be considered as error. So for successful termination, you need to write 0. Okay, one thing more I want to add here, this line in work process and this line where you actually declaring this prototype. These two lines are not necessary if you are running your code in debugging mode. In debugging mode, what we will do, we will be running only these assembly lines. But if you are creating 32-bit application for x86 systems, then this is important part because it will actually terminate your application, 32-bit application. So during these video series, when we are learning the assembly language programming, you can actually simply avoid these two lines, okay? These two lines. But if you are creating a 32-bit application, then you cannot avoid these lines, okay? Remember, I've just used the template from the Kip Irvine book, okay? And why we are doing so? Because we will be using Irvine library. In Irvine library, you will have to use these kind of standard uh, uh, program templates. So whenever you're gonna write your code, you will be changing somewhere over here. And whenever you want to create some variables, you will be creating your variables over here. The rest of the template will never change. Okay. So I hope you understand the various uh, segments or various parts of this standard assembly language program for Kip Irvine library. Uh, I've tried to explain you the standard template. If you have any query, you can post your queries in comment section. Thank you so much for listening.